हाय एवरीवन, गुड मॉर्निंग। माय नेम इज़ विराज और मैं रहूँगा आपका फिजिक्स टीचर। इस सेशन में हम लोग जो है आगे पढ़ाई करेंगे, फंडामेंटल्स बिल्ड करेंगे, क्वेश्चन भी करेंगे और नीट के हिसाब से अपने टॉपिक्स को प्रिपेयर करेंगे। बट उसे स्टार्ट करने से पहले लेट्स लुक एट दिस फ्यू अनाउंसमेंट। हम लोग जो है न्यू बैच शुरू कर रहे हैं। ये अप्रैल 2025 से शुरू हो रहा है। ये 2 ईयर प्रोग्राम है। ये प्रोग्राम उन बच्चों के लिए हेल्पफुल रहेगा जो बच्चे 10th से 11th में जा रहे हैं और अपना नीट यूजी का प्रिपरेशन के लिए वन स्टॉप सॉल्यूशन ढूंढ रहे हैं। देखिए, इस बैच में बायोलॉजी सचिन सर और वर्षा मैम पढ़ाएंगे। सचिन सर का एक्सपीरियंस देखिए, 25 ईयर्स ऑफ एक्सपीरियंस। जितना आपका एज नहीं है उससे ज़्यादा साल से सर पढ़ा रहे हैं। ठीक है, तो आप बायोलॉजी जो है हमारी टीम पे जो है एकदम 360 मार्क्स यहाँ पर छोड़ दीजिए, आपका पूरा सिक्योर हो जाएगा। विनीत सर कोटा के बहुत बड़े टीचर हैं केमिस्ट्री के, 12-13 साल से कोटा में पढ़ा रहे हैं। सर एटीपी स्टार जो है उनका अपना इंस्टीट्यूट रन करते हैं विच इज़ इन कोलेबोरेशन विद iQuanta नाउ। मैं आपको फिजिक्स पढ़ाऊंगा। ठीक है, मैं पिछले 8-9 साल से फिजिक्स पढ़ा रहा हूँ। 2016 से बिट्स पिलानी से मैंने अपना ग्रेजुएशन किया है और मेरे पढ़ाए हुए बच्चे बहुत सारे ना कि जब भी MBBS में हैं बल्कि ऑलरेडी डॉक्टर भी बन चुके हैं। ठीक है, तो ये बैच उनके लिए रहेगा। इस बैच में जो फीचर हैं बेसिकली लाइव क्लासेस थ्योरी में रहेंगी, एक लाइव एप्लीकेशन क्लासेस रहेंगे जिसमें हम क्या करते हैं, सिर्फ आपको लाइव क्वेश्चंस भी कराएंगे जो आपकी बुक्स आपको सजेस्ट की जाएंगी, ना कि आपको करने को बोला जाएगा बट कि हमारी तरफ से भी कराई जाएंगी। तो यहाँ पर आपको लाइव थ्योरी क्लासेस, लाइव एप्लीकेशन क्लासेस और जो आपके जो डाउट सॉल्विंग के फीचर हैं 24/7 डाउट सॉल्विंग के लिए। आप कभी भी आपका डाउट है यू कैन पोस्ट इट एंड गेट इट सोल्व्ड। ठीक है, 8 से 9 मिनट के अंदर आपका जो है डाउट आपके पास रिजोल्व होकर के पहुंच जाता है। ठीक है, सेकंड बैच जो हम लोग जो है 12th के लिए, जो 11th से 12th में जा रहे हैं और जिनको लगता है कि उनका 11th वीक रह गया, उनके पोर्शन जो है कुछ कमी रह गई, अच्छे से प्रिपेयर नहीं कर पाए या खुद ही सीरियस नहीं थे, सीरियस थे बट स्कूल के साथ मैनेज नहीं कर पाए, तो उनके लिए जो है संजीवनी बैच 1 ईयर प्रोग्राम है। टीम हमारी वही एक्सपर्ट की सेम रहने वाली है। ठीक है, इसमें इंद्रजीत सिंह सर जो है हमारे फाउंडर एंड CEO, ये आपको कंसिस्टेंटली मेंटरशिप और गाइडेंस के लिए अवेलेबल रहेंगे। ठीक है, और आपसे बीच बीच में जो है इंटरेक्टिव सेशन रखेंगे जिसमें वो आपको लाइफ कोच की तरह जो है अच्छे से गाइड करते रहेंगे कि अप्स एंड डाउन्स आप एग्जाम के टाइम में मैनेज भी कर पाओ। क्लियर? तो ये 1 ईयर कोर्स रहेगा, नीट फोकस रहने वाला है और इसमें भी आपके लाइव एप्लीकेशन क्लासेस जो है 12th के लिए, लाइव थ्योरी क्लासेस, प्रैक्टिस, AI बेस्ड मॉक टेस्ट सीरीज। ठीक है, तो सारे फीचर जो एक अच्छे कोर्स के अंदर होने चाहिए, जो बेहतरीन कोर्स के अंदर होने चाहिए, वो सारे इन दोनों बैचेस में आपको मिल जाएंगे। ठीक है, इसके लिए सर हमें इनरोल कहाँ से करना पड़ेगा? अगर इन बैचेस में आप इंटरेस्टेड रहोगे तो आपको iQuanta की वेबसाइट पर जाना है और वहाँ पर नीट के कोर्स के लिए इनरोल करने के लिए जाओगे तो आप ढूंढ लोगे। ठीक है, और इसके अलावा आपको जो डिस्क्रिप्शन में देखिए वो एक व्हाट्सएप ग्रुप का भी लिंक दिया हुआ है और एक गूगल फॉर्म डिस्क्रिप्शन में दिया हुआ है। उस गूगल फॉर्म को आप फिल कर दीजिए और उसमें अपना क्वेरी रेज कर दीजिए कि मुझे सर ये प्रॉब्लम हुई है, जैसे 11th मेरा 50% हुआ है, मैं बाकी जो है नहीं कर पाया। तो डिफरेंट क्वेरीज जब हमारे पास आएंगी तो हम उसको बेटर तरीके से रिजोल्व करने में हेल्प करेंगे। ठीक है, वी कैन कीप सम जूम सेशन, वेबिनार ऑल्सो विद यू, ताकि हम लाइव इंटरेक्शन जो है कर पाएँ और आपके जो है क्वेरीज को रिजोल्व भी कर पाएँ। ठीक है, आपको किस तरीके से जो है एग्जाम को डील करने में जो जो मुश्किल हो रही है क्वेरी में आप पुट कर सकते हो। ठीक है, तो गूगल फॉर्म भी फिल कर दीजिए और व्हाट्सएप ग्रुप ज्वाइन कर लीजिए जहां पर आपको जो हम लोग फ्री स्टडी मटेरियल शेयर करते हैं, क्लासेस की इन्फॉर्मेशन आती हैं। ठीक है, और जो भी नीट से रिलेटेड कोई भी अपडेट या कोई भी एग्जाम अपडेट आपको मिलता है तो उस ग्रुप में शेयर कर दिया जाता है। ठीक है, तो दिस वॉज सम अनाउंसमेंट। सो लेट्स स्टार्ट द चैप्टर एंड अच्छे से पढ़ते रहिए। बेस्ट विशेष। तो चलिए स्टार्ट करते हैं लेक्चर को। यस, यू कैन कीप अ नोट। So let's go to the next topic, which is subtraction of vector. How we will subtract two vectors? See, subtraction of two vectors is just like adding a negative vector of 1 into another vector. Like if you want to calculate a minus b, what we will do? We will add minus b vector in a vector. So we will add minus b, that is adding a negative vector into another vector. Clear? that we call as subtraction. See, we have a vector, we have a vector, we have b vector is also given. We know the angle between them. This is angle between them is theta. Now I want to know what is the value of a minus b vector. So we will use this formula. We will add minus b with a vector. So what is minus b? Opposite to b vector. So this would be your minus b vector. So this would be your minus b. We have a and we have minus b. What is the angle between a and minus b? This is nothing but 180 degree minus theta, pi minus theta. Now, using triangle law, what we can write, if two vectors are represented by adjacent sides of a triangle given in same order, then the third side taken in opposite order will represent the sum of these two. So it will be sum of a and minus b. So a and minus b sum will be a minus b vector. So this will be the resultant vector, and its magnitude would be what? A square, magnitude of b square, twice of magnitude of a, magnitude of b, cosine of angle between them. Angle between a and minus b vector is 180 minus theta. And if I further solve it, what is cos 180 minus theta? It is minus cos theta. So you will get magnitude of a minus b would be under root of a square b square minus 2ab cos theta square root. Fine. So you will get this. And one more form we can see, change in a vector physical quantity means subtraction of initial vector from final vector. See, we have initial vector, suppose this is the initial velocity and this is the final velocity. A car is moving in this direction, suddenly changes its direction in this way. Then what is the change in velocity? Yani ki what we will be getting? V final minus V initial. V final minus V initial. We need to find change in vector quantity. What we will be writing? V final vector minus V initial vector. V initial is this direction. What is minus V initial? Opposite to it. So this will be minus V initial. What is V final? So parallel shifting can go here, and parallel shifting and also changing the direction. Opposite to V initial, we will be getting minus V initial. So we are getting V final and V initial. By using triangle law, we can get the third side. Adding V final and minus V initial, by adding these two vectors, we will get this delta V. Delta V is V final minus V initial. This will be the difference of these two vectors. Difference of these two vectors and addition of V final and minus V initial. Clear? So in this way also we can represent, and in this way also we can solve. So we have two methods to solve. They are more or like same, but just the representative method. Okay. And this we need to remember. Resultant would be a square plus b square minus 2ab cos theta, where theta is angle between a and b. Theta is the angle between a and b. Clear? Let's see one question on this, then we will be able to grab it. See, if magnitude of this a plus b and magnitude of a minus b, if this ratio is 1, then what is the angle between a and b? What is the angle between a vector and b vector? See, we can solve it with two methods. Suppose, let's take geometrical method, method 1. If angle between this and this is same, then there is only one possibility. There is only one possibility that this is a vector and this is b vector. So this would be the diagonal a plus b. What is minus b? This would be the minus b vector, and this is a minus b vector. Clear? So they both would be same, this diagonal and this diagonal, diagonal 1 and diagonal 2. So diagonal 1 and diagonal 2, they both would be same if and only if this angle would be 90 degree. If and only if geometrically we can see, if this angle is 90 degree, that means diagonal would be same for both these rectangles if and only if if for both these parallelogram, if and only if parallelogram is a rectangle. 90° should be the angle between A and B. This we can also solve mathematically also. Method 2, we will write magnitude of A plus B will be equal to magnitude of A minus B. This is the form. Now, if I solve it, we can write root of A square B square plus 2AB cosine of theta will be equal to square root of A square B square minus 2AB cos theta. This will cancel out, this will cancel out, this will cancel out. So many of the things will get cancelled out. So what would remain? 2AB cosine of theta will be equal to minus 2AB cosine of theta. We can further write it down. 4AB cosine of theta will be equal to 0. Will be equal to 0. It means cosine of theta will be equal to 0. This means theta must be 90°. Any option? Yes, option number C. We can also solve in this way. There are two methods to solve, that is diagonal. Diagonals are same if and only if they are, this parallelogram is a rectangle, and we can also prove it like this. So you have two options to solve this question. So whichever you feel like, okay, so you can take it. Now the next question, the resultant of two vectors P vector and Q vector is R vector, and if Q is reversed, then the resultant becomes S vector. That means R vector is nothing but P plus Q and S vector is nothing but P minus Q, because in the second statement it is saying the direction of Q is reversed. Reverse means subtraction. Then choose the correct statement. Which of the following statement is correct? From here we can write R square is equal to P square plus Q square plus 2PQ cosine of theta. From here we can write S square equal to P square plus Q square minus 2PQ cosine of theta. If I add these two equations, so it will get cancelled out. So we will write R square plus S square equal to twice of P square plus Q square. We can simplify it in this way. Any option? Yes, I think option number B would be there. Clear? So it's a very easy question. Let's go to the next topic. The next topic is resolution of vector. A vector can be resolved in its rectangular component along 2D direction and in 3D direction also. A vector can be resolved in its rectangular component in 2D form and in 3D form also. Like, it is a convention to resolve a general vector along the axis of rectangular coordinate system using a vectors of unit magnitude, which we call as I cap, j cap and k cap, and the unit vectors are along x axis, y axis and z axis. So any given vector can be resolved in three components: I cap, j cap and k cap. So any vector can be resolved in three components: ax I cap plus ay j cap plus az k cap. This means ax is the effect of this vector along x axis, ay is effect of this vector along y axis, az is effect of this vector along z axis. Example we can take, like if velocity is given as 3 I cap plus 2 j cap plus 4 k cap meter second. This means a particle is moving with a speed of 3 meter per second along x axis, 2 meter per second along z axis and 4 meter per second along z axis and 2 meter per second along y axis. Clear? This is one such example. Now, from this form, how we will calculate the magnitude of the vector and how we will calculate the direction of vector. So, we are going to study this only. Fine. So, let's resolve the vector first in the 2D form and then in the 3D form. Clear? Resolution of vector in 2 dimension. See, let us assume there is a vector A. It is making an angle theta with the x-axis and 90 minus theta with y-axis. Now, it has some component which we call as ax along I cap and ay along j cap. Fine. So, this vector can be written as ax I cap plus ay j cap. Now, what is ax and ay? From this diagram, if you write cos of theta, you will write base upon hypotenuse from this triangle. If you take base upon hypotenuse, so what you will get? Ax as a cos theta. So, this is one of the rectangular component. And what is this? Second perpendicular component is a cos theta. Now, how we will resolve a vector along two perpendicular component? How we will resolve a vector in two different rectangular components? See, a component along the direction of theta, which is making an angle theta with the vector, is given by a cos theta. And a component perpendicular to the vector, the second component perpendicular to the given direction, is a sin theta. We can understood in this way. Suppose there is a vector A and there is some random direction which is making an angle theta with A. So, what is this component? A theta. Component of A along this direction, A theta. So, A theta would be nothing but A cos theta. This component of this along this direction, yani this component, this length only. So, this length would be A cos theta only. And the second component perpendicular to the direction, this component would be A sin theta. This is A perpendicular component. Get it? So, any vector can be resolved into two components, A cos theta along the given direction and A sin theta perpendicular to the given direction. This we call as resolution of a vector. Vector can be resolved in two mutually perpendicular components. Okay. And for x-axis and y-axis, we can say this must be ax and this must be ay. Clear? If the angle is with x-axis, so a cos theta is ax and a sin theta would be ay. Clear? If any random direction is given, so along the direction a cos theta perpendicular to the direction a sin theta. Now, if the vector A is written in this form only, A vector is nothing but ax I cap plus ay j cap. Here we know what is ax, a cos theta, and what is ay, a sin theta. One way we can resolve in this component. Otherwise, if this only Cartesian form is given, then how we will write the magnitude? This magnitude of A vector will be written as under root of square root of ax square plus ay square. Coefficient of x square plus coefficient of y square. This would be the magnitude. Its magnitude A and direction theta with the x-axis, its component ax and ay. So, the magnitude A can be written as this. Direction, from this you can write, this is your ay, this side, and this side would be your ax. If we take the ratio, so you will write tangent theta, you can write tangent theta as ay by AX. This is the angle made by the vector with the x-axis. AY by AX, perpendicular upon base. Clear? So we can resolve vector in Cartesian form. We can write Cartesian form as A cos theta and A sin theta also if you want to write. Otherwise, if Cartesian form is given, then its magnitude can be written as coefficient of x square, coefficient of y square, and if z is also there, then coefficient of z square also. Clear? Yes, tell me. Now, let us take this example. 2 kg weight, 2 kg mass lies on an inclined plane. Resolve the weight along perpendicular to the plane. Along the plane and perpendicular to the plane. What is the weight? This would be the weight. Weight is 20 Newton only. Mg. M into G. So mg would be 2 into 10, 20 Newton. Now I need to resolve this weight, this vector, weight vector, along the perpendicular direction, perpendicular to the plane, and the second direction is along the plane. If this vector is theta, then this is 90 minus theta. If this is 30, then this is 60. And this total angle is again 90. So we can write this is again 30. So if this is theta, then this is theta. Then mg will have what component along this direction? So along a given direction, it will have mg cos theta. And here it will have a component of mg sin theta. So this is perpendicular to the plane and this is along the plane. Put the value. Mg is 20. This would be 20 sin 30 degree. And what would be this value? 20 cos 30 degree. What is 20 sin 30? This would be 10 Newton only. So along the plane it will have 10 Newton component. What would be this value? This is 10 root 3 Newton. Fine. So this would be the answer and this would be the answer for perpendicular and along the plane. Clear? This is how you resolve a given vector along its perpendicular component. Let us take one more example. A vector makes an angle 30 degree with horizontal. It is making 30 degree with the horizontal. Its horizontal component is 250. That means it is saying this component along horizontal direction, this is horizontal. It is saying this AX, which we say as A cos 30, its value is 250. Then find the magnitude of vector and its vertical component. Its vertical component would be this, which is AY, which is nothing but A sin theta. That is A sin 30 degree. Clear? Now we have A cos 30. From here we can write it is 250. What is cos 30? Root 3 by 2. It comes out to be A is 250. We can write as 500 upon root 3. This would be the magnitude of vector. What is the vertical component? Vertical component is AY. AY is nothing but A sin just a minute. We can write it as A sin 30. A sin 30. What is A? 500 upon root 3. What is sin 30? 1 by root 2. Clear? So you will get the value as 250 upon root 3. If you want to rationalize, you can rationalize this also and rationalize this also. Okay. Divide and multiply with square root 3. Clear? So in this way also we can get some basic question. Let us solve vector when it is given in 3D form, 3D Cartesian form. A vector can be written as ax I cap, ay j cap plus az k cap. That is, any random vector, any given vector can be resolved in three component ax, ay and az. It will be making some angle with x-axis, some beta angle with y-axis and some gamma angle with z-axis. Okay, now we have two things to find out. Whenever we want to explain any vector, we need two things. One is vector magnitude, other one is directions of vector. Directions means angle made by the vector with a different axis, x, y and z. Now, for this vector, the magnitude of vector can be written as root of a square plus ay square plus az square, ax square plus ay square plus az square. What you need to do while calculating magnitude from a Cartesian form, we will be solving coefficient of x square, coefficient of y square plus coefficient of z square and take the square root of whole sum. Clear? This would be giving us magnitude of a vector. Clear? Now, direction. From this diagram, we can write ax as a cos alpha, ay as a cos beta and az as a cos gamma, because we have already learned a vector can be resolved along any direction. So, if it is making alpha angle with x-axis, so its component would be a cos alpha. Here it is making angle beta with y-axis, so a cos beta is the component. Here a cos gamma, where cos alpha, cos beta and cos gamma are termed as direction cosines. Direction cosines. This is very important term. This is very important term. Direction cosines of a vector. So, direction cosines are cos alpha, value of cos alpha, cos gamma and cos beta. What is cos alpha? From here we can write, what is cos alpha? We can write it is nothing but ax upon magnitude of a. What is cos beta? From here we can write, what is cos beta? Cos beta can be written as ay upon magnitude of b. What is cos gamma? What is cos gamma? Cos gamma can be written as az upon magnitude of a. These things are called direction cosines because they contain cosine function and they also contain angle made by the vector with different axis, which is nothing but direction of a vector with respect to a coordinate frame. So, that's why direction for alpha and cosine for cos function. So, direction cosines are cosine values which gives angle made by the vector with the coordinate system. Clear? So, if I want to calculate angle made by the vector with x axis, which is alpha, so I will use cos alpha is ax by a magnitude, cos beta is ay by a magnitude. So, in this way alpha, beta and gamma, all three angles can be calculated. Clear? Because I already know this denominator. This is under root of ax square plus ay square plus az square. So, we can calculate these direction cosines. And one more thing, if you square both sides for this and for this, for all these three terms, if I want to calculate cos square alpha plus cos square beta plus cos square gamma, then you will get this equation will be equal to 1 only. So, this is very important point. What type of questions are asked from this? Suppose a vector is making 30-degree angle with x-axis, 45-degree with y-axis, then what is the angle made by the vector with z-axis? So, such type of questions are asked from this equation. Okay. So, this is a relation between direction cosines and these are the value of direction cosines. This is the magnitude of the vector and this is the Cartesian form of the vector. Clear? So let's solve one example. We will be able to solve it. See, a vector A, B, C have magnitude 5, 5 root 2 and 5 respectively, and direction of A, B and C are east, northeast and north. Suppose this is your east, this is your north and this is your northeast. So vector A is along east direction. Vector A is along east direction. Okay. So this would be your vector A. This would be your vector A and it has 5 unit vector A. Magnitude of 5 Newton. So it we can write as 5 I cap. Suppose this direction is I cap. So this direction is J cap. So vector C is along north. Vector C is along north. It is also having a magnitude of 5. So vector C, which is 5 J cap, can be drawn here. Then one more vector is there. One more vector is there. Vector B. Its magnitude is 5 root 2 and it is in northeast direction. Northeast means it is making 45 degree with east and 45 degree with west. Now I need to express A plus B plus C. I need to find resultant of all these three. A vector plus B vector plus C vector. I need to express in I cap and J cap term. First of all, you resolve this vector along two components. Resolve B vector, because B vector is not along I cap and neither it is along J cap. So it is in some random direction. We can resolve it along x axis and y axis. So what is the component of B along this direction? Component of B along this direction. So we will write B cos theta along A cap. Sorry, I cap. And what is the component of B along this direction? Component of B. We will write B sin 45. Here we can also put this theta as 45 degree. So let's put this theta as 45 and here also 45. So we'll get these two components. So what is the total vector along x axis? This. What is the total vector along z axis? Sorry, j axis will be this. So this r vector can be written as 5 I cap plus this b can be written as 5 root 2 then cos 45 along I cap, and this b vector can be written as 5 root 2 sin 45 along j cap, sin 45 degree along j cap, and plus c vector also I can write plus 5 j cap. Now 1 by root 2 and cos 45 will get cancelled out. 1 by root 2 and cos 45 will root 2 and cos 45 cos. So what is r vector? Resultant vector. So you will write 5 I cap. From here you will get 5 I cap. From there you will get 5 j cap plus 5 j cap. So you will write r as 10 I cap plus 10 j cap. So this would be the magnitude. What is the magnitude? R magnitude can be written as square root of 10 square plus 10 square, that is 10 root 2. Then this is the magnitude of R. What is the direction of resultant? Direction. Now this is the important point. Direction. Direction, it is saying what is the unit vector r cap. Unit vector is nothing but r cap. R cap is r vector by r magnitude. This is called direction of r cap, direction of r vector. Resultant vector direction is given by r vector by r magnitude. Dividing a vector by its magnitude will give direction of R. Then what is R vector? 10 I cap plus 10 j cap. Then what is the magnitude? It is 10 root 2. Then what is R cap? R cap can be written as 1 by root 2 I cap plus 1 by root 2 j cap. That is, this is the unit vector of parent vector R. This is the unit vector of parent vector R. So here we will get all the applications. One is resolution of component of any random vector. Then addition of vector I cap and j cap and j cap. I cap will get added into I cap and j cap will get added with j cap component. Then we will get the resultant. How to find the magnitude of the resultant? This way. And how to find the direction, which is R cap. So this is the takeaway. Direction of any vector is nothing but unit vector of that vector. Unit vector of that parent vector will give its direction. So whenever we need to ask, whenever we get to find the direction, what we will be solving? We will be solving the unit vector of that parent vector. Clear? Fine. Let's take one more example. Obtain the magnitude and direction cosine of A minus B vector. Obtain the magnitude and direction cosine of this vector. What is A minus B? We have vector A and we also have vector B. What is vector A? A vector is given as 2 I cap, 3 j cap plus k cap. What is B vector? B vector is given as 2 I cap plus 2 j cap plus 3 k cap. Then what is A minus B vector? So if I subtract, so I will get, what I will get? 0 I cap plus j cap minus 2 k cap. So this is the A minus B vector. Now I need to find its magnitude. Find the magnitude of A vector minus B vector. What will be the magnitude? 0 square plus 1 square plus minus 2 whole square. So I will be getting root 5 from here. What is the direction cosine of vector? Direction cosine. So this is nothing but, suppose this is your R vector, resultant vector. So this is what? Rx. This is what? Ry. And this is what? Rz. And this is what? R magnitude. So direction cosine. What is cos alpha? What is cos alpha? 0 by root 5. Rx by R magnitude. What is cos beta? What is cos beta? 1 by root 5. 1 by root 5. That is Ry by R mod. What is cos of gamma? We can write it is Rz by R mod. So what it will be? Minus 2 by root 5. So these are the direction cosine. 0, minus 2 by root 5, 1 by root 5. Any option? This one. 0, 1 by root 5 and minus 2 by root 5. And magnitude we have already calculated. This is the magnitude part. Clear? So any vector can be resolved in 3 components. Any vector can be resolved in 3 components, x, y and z. We can calculate unit vector from there and we can calculate magnitude from there. Unit vector contains directions and magnitude contains the length of the vector. Clear? Yeah. So this is how we will add and subtract and solve the Cartesian form of a vector.